All right, in this video, I'm going to go over graphing stretches and compressions. Now, what does that mean? It means we're going to take a normal graph like f of x equals x squared, simple parabola, and we're going to stretch it and compress it. And I'll show you what that means. So first of all, we're going to stretch vertically. So a vertical stretch, or stretch it vertically. Now, how do we do that to the function? Well, we take the function and we multiply it by whatever factor they ask us to, right? So we're multiplying it by a factor of 2. That's the easiest one, right? So 2 times f of x would be 2x squared, right? Because f of x is x squared. So we're just multiplying that whole thing by 2. Easy. Okay, now let's graph it, right? Well, it's going to be almost the same as this. It's just going to be multiplied by 2, right? What we're doing here is we're multiplying the outputs by 2. Inputs will be the same. So 0 squared is 0, times 2 is 0. Okay, that was easy. Now what? 1 squared is 1, times 2. Okay, so 1 times 2 is 2. So we move over 1, input is 1, up 2. Because our output is 2. Okay, so right away, we've changed it a bit. Okay, what's next? Well, negative 1 will get us the same thing, right? Because it's being squared. So negative 1, 2. Parabolas. Essentially, a simple parabola like this is an even function. It's the same when you reflect it across the y-axis. So anything we graph over here will be the same on the other side, right? So what about 2? Put in a 2 there for our input. 2 squared is 4 times another 2, which is 8. So we go up 8. Oof. All the way up here. All right. Forgive my crude drawing, but as long as it gets us there, all the way up there, right? Now 3 squared is 9, times 2 is 18. That's way up there. It's kind of off the board here. So we're just going to graph it like this. Zoop. And that is a vertical stretch. We took this, we made it kind of stretch, and it goes up faster, which is really what it's doing, but we're just kind of stretching it. Okay? Now, what about a vertical? Hold on, let me use a different color marker here. What about a vertical compression now? How do we do that? Well, instead of multiplying our function by a factor, we're going to divide our function by a factor. Some textbooks say multiply by a number less than 1, but that's what fractions are. They're just numbers in between 0 and 1, usually, unless you're talking mixed fractions. But anyways, so let's just divide it by 2. So what do we get? X squared over 2. Okay. We're dividing our output by 2. So our output is just going to be really small all of a sudden. Okay, what does that mean? Well, let's graph it. Plug in 0. 0 divided by 2 is still 0. So we're starting at the same spot, right? The same origin point. That is okay. What if we put a 1 in there? End up with 1/2. Okay, we're not going very fast here. Put a 2 there. 2 squared is 4 divided by 2 is 2. So 2, 2. Okay, I see how we're doing this now. 3. 3 squared is 9 divided by 2, about 4.5, right? 1, 2, 3, 4.5. Zoop. Right about there. 4. 4 squared is 16 divided by 2 is 8. All the way up here. We're still rising. It's still a parabola. But what's happening is we're compressing it down vertically. We're compressing it. You know? Some people think compression means you're squeezing it, so they get confused and they think that first one is squeezing it, but there's a compression, but this is compression. Patting it down. Vertical compression. Now, I think that's enough points for us, right? And we take a more smooth slope there, and then we come back up. And that's how you stretch vertically and compress vertically. All right, so next we're going to go over horizontal stretch and horizontal compression, and we'll talk about the difference or the similarity. All right, we've gone over vertical stretch and vertical compression, and I superimposed those graphs onto our original graph, so we remember where those line up. Now, for a horizontal stretch, math is a little different. Instead of manipulating or multiplying the output by a factor, we're going to divide the input by a factor. Divide input. Okay, it's going to be confusing. For vertical stretch, we multiplied the output. For horizontal stretch, we're going to divide the input. It's kind of the exact opposite. So, f of x divided by 2. Right? We put in x over 2 for x, and this is what we get. Now, we need to simplify that a little bit to make it easier for you. X squared over 4, right? X over 2 times x over 2. X times x is x squared. 2 times 2 is 4. All right. So let's graph that. 0. 0 divided by 4 is still 0. Okay, that was easy. 1 squared. Okay. Divided by 4 is 1/4. Ooh. And we didn't go very far, did we? 2 squared is 4. Divided by 4 is 1. Okay, we're making some vertical progress here. Let's just skip to 4 squared. It's an even number. 4 squared. 16 divided by 4 is 4. Okay. Got it. Negative 4, 4, 4, 4. Okay, I think we see where this is going. Making a very wide arch there. Very wide. That is a horizontal stretch. It's stretching out, you know. Does that remind you of anything? Looks like vertical compression, doesn't it? That's pretty much what happens. Although this gets you there, you know, gets you out wider, faster, because for a vertical compression, remember it was x squared over 2, not x squared over 4. All right. Well, let's Got another marker. And let's do the horizontal compression. What does the horizontal compression do? Well, if we were dividing the input here, we're going to multiply the input here by a factor, right? So we're going to have f of 2x, right? So we plug in 2x for our input of our original function, right? 2x times 2x is 4x squared, right? So now let's graph that and see what we get. Start at the 0, 0, yeah. 1 squared is 1 times 4. Ooh, 1, 2, 3, 4. That shot right up there, didn't it? Okay, 2 squared is 4 times 4 is 16. What the? 2. 14, 15, 16. Well, that's way up there. Let's just do that and call it good, right? Zoom. That really, really compressed it down. Horizontal compression. That is how you do that. See how horizontal compression is about the same as a vertical stretch, and a horizontal stretch is about the same as vertical compression. It's going to be confusing. But since they're both kind of the same thing, maybe you could just stick with one of them, you know, just stick to vertical stretching, you know, just make sure you remember one, the vertical or the horizontal, whichever one you prefer. And just remember that the other one is the exact opposite. All right, one last thing before we wrap this up. Don't have to look at my sad graphing skills right for this part. So it's a bit of a relief for me. All right, so we have a set of data, just a table, right? And they're asking us to give us a new set, two new sets of data by taking this data and vertically stretching it by a factor of 3 and then horizontally compressing it by a factor of 4. Okay, so let's work on the vertical stretch first. Okay, what does that mean to vertically stretch it? We multiply the output by the factor, right? Multiply the output by the factor. So input stays the same. -2, -1, 0, 1, 2, 3, right? The output is multiplied by the factor that they gave us, which is 3. So 3 f of x is what? 5 times 3? 15. That was easy. 4 times 3? 12. Okay, 3 times 3? 9. Got it. -2 times 3? -6, right? -4 times 3? -12. -8 times 3? -24. All right? That's all we did. Now, what about horizontal compression? Okay. So, horizontal compression, remember that? We multiply the input by the factor. It's the opposite of what the vertical compression would have been, which would have been division, right? Because the vertical stretch is multiplication. So horizontal compression is multiplying by the input by the factor. Oh, don't get confused. So f of x, our output stays the same. right? Input changes to 4 times x. 4 times -2, -8. 4 times -1, -4. 4 times 0, 0. That came out looking like a theta. Let's erase that. Okay. Still looks weird. Anyways, 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. And that's it. Just remember, if it was horizontal stretch, we would be dividing by 4. Right? And if it was vertical compression, we'd be dividing by 3. Oh, thank you for watching. On a side note, what is this knowledge good for? Well, when you're graphing something, it would be helpful if you had a like predetermined image already in your mind when you see the function, you know, the 2x squared minus 7x plus 10, you know, you would already have this picture in your mind. Okay, 2x squared, that is kind of a skinny parabola. You know, you already have that image in your mind. So it's just a good note to explain why we're learning this.